This is William Michael of the Classical Liberal Arts Academy, and this is the first hour of instruction in freshman science in the Academy's high school diploma program. In this freshman year of science, we're going to study the science of biology, that is, the science of life. Selective colleges and universities seek students who pursue 4 years of the study of the natural sciences in high school, and the normal course of studies for high school students begins with biology in the freshman year, then studies chemistry in the sophomore year, then moves on to physics in the junior year because physics relies on the use of algebra, and so it's important that a student has made progress in mathematics so that he can do the work that's required in physics class. And then that leaves 1 year of high school study available for advanced studies in natural science. So in the Academy's high school program, we're going to focus on the first 3 years, which provide the basic science courses in biology, chemistry, and physics, and then that will leave some time in the senior year for an advanced study in science. That can be a study like anatomy, or it could be AP courses in preparation for AP science exams, and we'll talk about those some other time. If you have questions about preparing for college admission and would like to talk about what courses and studies you should try to complete or gain experience with, feel free to contact me at any time. But if you're in your freshman year and you're interested in studying the natural sciences, you should just concentrate on freshman science and the study of biology. In this biology course, in this freshman science course, we're going to work through a general biology textbook that's well known historically and is useful for modern students. While technology allows us to do many things, our actual knowledge of the natural world hasn't increased very much, at least in general knowledge of the natural world, since the advent or the beginning of the scientific method. There have been breakthroughs in certain different studies, there have been developments over time, but we'll never understand these developments. We'll never understand where the sciences are at present unless we go back and study carefully the general sciences, and then leave the study of the state of the sciences today or the developments that have occurred recently in the sciences for studies after we already understand the general sciences. So we'll get to the state of the sciences today and what scientists currently are teaching and studying in the future, but it's going to take some time for students to simply learn the general knowledge that's been available for centuries regarding the general sciences, biology, chemistry, and physics. So in this course, we're just going to focus on the study of general biology, laying a foundation for future advanced studies. Next year, we'll work through chemistry in the same way, and then through physics, and then hopefully you'll have some time before college admission to work through some advanced science studies near the end of your high school years. In this first hour, we're going to walk through the first chapter in our biology textbook and study an introduction to biology. And you can see on the first page of your biology textbook in the lesson that Part one is the study of botany, and that means plants. Part one will study botany. In part two, we'll study zoology. And then in part three, we'll study human physiology, that is, the form and function of the parts of the human body. So, three parts in our study of biology: botany, the study of plants; zoology, the study of animals; and human physiology, focusing on the bodies, the form and the functions of the human body. That's the outline for our study of biology in freshman science. In addition to these basic textbook studies and discussions, we'll also add laboratory exercises. And you may wonder and say, how can I do laboratory exercises if I'm studying in an online course? Well, 20 years ago, laboratory exercises were very important because in schools at that time, the only way that students could learn about things was by experiments, by activities in labs where they could see things that they otherwise couldn't see. But today, our access to videos and information has changed so much that there are many things that we can learn. We can learn much of laboratory science by simply watching helpful videos produced by laboratory scientists and laboratory teachers, and follow some basic instructions to complete some simple laboratory activities or experiments at home. So the requirements of laboratory studies is really not that complicated, and it's not like it was 20 or 30 years ago, where if students didn't perform certain activities in a laboratory, they had no way of seeing or experiencing those lessons. We don't have that problem today. So we'll cover all of the content of laboratory studies in biology in our course as we go along. That'll be no problem. For this first lesson, as I said, we're going to walk through an introduction to the study of biology in general, even to science in general, and we're going to learn and discuss some important issues. So listen carefully, study this lesson carefully, and make sure you get off to a good start in the study of the natural sciences and lay a good foundation, making sure you understand the basic principles on which all real scientific study is based. So let's go ahead and jump right into this and get started with lesson 1 in biology of freshman science. The lesson begins with an introduction, and the first topic is science and matter. Science and matter. And let's make a goal for this first part of the study to learn what we mean by the terms science and matter. Science and matter. The lesson reads, science deals with that material which occupies all the space around us. Science deals with that material which occupies all the space around us, the air, the water, and the earth. This material is called matter. This material that occupies the space around us in this world, this material is called matter. So the first thing we can do is understand what matter is. Matter is the material of the natural world. The next sentence reads, matter is the building material of the world in which we live. So matter being the material, it's that which we can sense. in this world. It's the stuff that we can see, that we can smell, that we can taste, that we can hear, that we can feel. The stuff in this world that we can perceive with our senses, the material of this world, is called matter. Matter. Science deals with matter. By the word science, we mean knowledge, and we mean a certain kind of knowledge. If you see someone that you saw someplace else, and you say to yourself, I've seen that person before, I know him, I know that person. That kind of knowledge, where you simply have seen something before, is what it means to be familiar with something. You say, I'm familiar with that. It means that I've seen it before, but I don't understand it. I don't really know much about it. I'm just familiar with it. And there's a lot of information that we're just familiar with. I know a little bit, for example, about roller skating. I don't know very much about roller skating, but I'm familiar with it. I know a little bit about soccer, but I've never really played soccer. I don't know the rules of soccer. I couldn't coach a soccer team or teach someone how to play soccer. I'm familiar with soccer, but I don't know soccer. When we talk about science, we talk about a knowledge that's based on experience, a thorough knowledge, a proven knowledge, a knowledge that's certain about something. Science is a systematic knowledge of some subject. It's a certain kind of knowledge, a certain quality of knowledge. Science is not familiarity. Science is not beliefs. Science is not opinions. Science is knowledge based on experience, thorough knowledge, systematic knowledge, the knowledge of the causes of things, the knowledge of the parts of which things are made, the understanding of how things work, how things live and grow, how they do what they do, what the causes of their activities are. That's real scientific knowledge, and that's the kind of knowledge that we seek in the natural sciences. But it's very important, especially for Christian students. It's very important to see what this very first sentence in our textbook has to say. Science deals with material. Science deals with material. When we talk about biology and chemistry and physics, we're talking about the study of matter, the study of material, the study of the physical world around us, the world that we can see and feel and hear and smell and taste. The material world is the subject of modern science. So science does not deal with questions about religion. Science does not deal with questions about history. Science doesn't deal with things in the future. Science doesn't explain where the world came from, or whether there's a God, or whether there are angels or spirits, or whether man has a soul. These things are not material. These things are immaterial or spiritual. And science does not deal with spiritual questions or spiritual topics. Science deals with matter, and matter is the material of the world in which we live. This is a very, very important lesson. And if you keep this in mind through all of your years of science studies, this very simple information learned in the very first sentence of freshman science will protect you from many, many errors in thinking. Always remember that science deals with material. Science deals with matter. I'm going to say it again and again. Science deals with matter, with the material of the world around us. It cannot answer questions about things that are not material. And if you always remember to only use the natural sciences for the study of questions that relate to matter, you'll save yourself from a great deal of confusion and error in the future. Science deals with matter, and matter is the building material of the world in which we live. Our lesson goes on to teach that matter, the material in the world, matter exists in this world in two distinct or different states. Matter exists in this world in two different states. It may be living or may have been alive at some previous time. It may be living or capable of living or formerly living. And this kind of matter is called organic matter. Organic matter. Organic matter is matter that is living or has lived in the past. Just to clarify that a little bit, if you go outside and you see a living plant, you see the grass on the front lawn or the leaves, the green leaves in the trees outside, if you see an animal walking across the yard, or even look at yourself, you see a living body, a living being. This is organic matter. But if you were to find the body of a dead animal, let's say in the woods, if you were to see the body of a dead tree, the trunk of a tree that had fallen over and is now dead and is decaying, both living animals and living plants and dead animals and plants are all organic matter. Organic matter doesn't just mean things that are alive or matter that is alive at present. It means matter that is alive or matter that was at some time alive. This is organic matter. The other state of matter, remember there are two states of matter in this world. The other state of matter is called inorganic matter. Inorganic. That means not organic. So the two states of matter are organic matter and inorganic matter. Organic matter is matter, material, that is living or has lived. Inorganic matter is matter that cannot live. matter that cannot live. An example of inorganic matter would be stone. Stone is an example of inorganic matter. If you find a stone, that stone is not living, and that stone has never lived before. A stone is inorganic matter. A piece of wood, an animal, a bone, skin, anything else that has lived or is living is organic matter. Anything that cannot live and has never lived is inorganic matter. So make sure you know the two states of matter in this world. So far we've talked about science, what science is. We said that science is a kind of knowledge. And we said that science deals with matter, and matter is the material of this world, the stuff that we can perceive with our senses. So we know what science is, and we know what matter is. And then we learned that there are two different states of matter in this world: organic matter, matter that is living or has lived, and inorganic matter, matter that cannot live, matter that has never lived and does not live and will never live. We then go on in our lesson to find a description or definition of biology, which is obviously very important since that's the title of this subject. We're studying biology. So what is biology? What is biology? Biology is the science which treats of matter in a living state. Biology is the science which treats of matter in a living state. Biology is the study of organic matter. Biology is the study of organic matter. Just so you know, the word biology, the first part of the word comes from a Greek word bios, and bios means life. The second part of the word, ology, means the study of or the science of. So biology is the study of life or the study of living matter. Biology is the science which treats of matter in a living state. The science of biology is broken or divided into two different parts, two different divisions of the science of biology. The two divisions of biology dealing with plant life and animal life are called botany and zoology. Botany is the study of plant life. Zoology is the study of animal life. Both of these are studies of living matter, of organic matter. Botany, the study of plants. Zoology, the study of animals. So now we know what biology is. Biology is the science which treats of matter in a living state. Now, as I said, science is a certain kind of knowledge. It's not familiarity, it's not opinion, it's not beliefs. It's knowledge that's based on experience or observation. We go on in our lesson to read a bit about science. Knowledge in science is gained by observation. Knowledge in science is gained by observation. And again, the reason why science cannot study spiritual things, science cannot study God or angels or any spirits or demons or the human soul or the origin of the world or the future of the world. Science cannot study these things because knowledge in science is gained by observation. By observation. Therefore, anything that we cannot observe with our senses, anything we cannot observe cannot be studied by science. Anything we cannot observe cannot be studied in science. Science has been defined as, quote, knowledge gained by exact observation and correct thinking. Science has been defined as knowledge gained by exact observation and correct thinking. First of all, science is a kind of knowledge. Science is a kind of knowledge. It is accurate knowledge. Again, not just familiarity, but accurate knowledge. It is possible to acquire a mass of knowledge that is not scientific with the sole aid of a textbook. We can learn a great deal with a textbook that's not necessarily scientific knowledge in this modern sense of the word scientific. It is possible to acquire a mass of knowledge that is not scientific with the sole aid of a textbook. Such a knowledge, for example, might be that of the Latin or the German language. Scientific knowledge, according to our definition, must be gained through observation. From the accurate study of a specimen. Make sure you pay attention to this word specimen. Specimen. S-P-E-C-I-M-E-N. Specimen. We gain scientific knowledge through observation of a specimen, something that we can see and touch. So if we study something with our senses, the thing that we study is called a specimen. It is not enough, for the sake of science, it is not enough to study a book alone. It's not enough for science to study a book alone. A book may be an aid. A book may help us, as this textbook that we study, you'll see, is going to help us. But the specimen is, after all, the main thing. The specimen is the main thing. Now, why is that? Why is the specimen the main thing in the study of science? Well, first of all, in science, we're seeking a knowledge of the material world. And the material world is the stuff that's around us, the objects that are around us, the things that we can see and touch and smell and taste and hear. The specimens that we can study are the actual matter of science. A textbook can tell us what other people have observed, so it is valuable in science. The knowledge that's shared in a textbook can be scientific knowledge because it may be based on another person's observations. But that person hasn't observed every specimen. There are many, many things that the author of a textbook hasn't observed, and we may observe things that the author of the textbook has never observed before. And therefore, scientific knowledge, in order for scientific knowledge to be tested, if the textbook says that this or that is true, the only way that we can know if the textbook is right is to look at a specimen and test it for ourselves. That's scientific knowledge. Scientific knowledge is based on observation. We observe and study specimens, physical things in this world, to gain scientific knowledge. Books are helpful, but the specimen is the main thing in science. We always want to prove and test whether something that someone says is true. Many writers in sciences, we'll see, are sharing theories that they use to try to explain what's going on in the natural world. They're theories. They're not necessarily true, and testing the theories, putting the theories to the test by experiments and studies of real specimens, is the whole point of science. The specimen is the main thing. Our lesson goes on and reads, if we were to fit ourselves for the trade of a plumber or a carpenter or a mason, if we wanted to be a plumber or a carpenter or a mason or any other kind of worker who had some skill and did some kind of work, any kind of skill, we certainly should not depend upon a book for our information regarding our particular trade. If a person wanted to become a carpenter, he wouldn't simply read a book and think that he was going to learn everything that he needed to know from a book. He would have to learn to cut wood, to measure wood, to fasten pieces together, to design things, to build things, to test things, to find out if the tables and chairs that he designed would actually be strong enough to use. We can't just prepare for physical works by studying books, but remember, the books are helpful. It's often a great way to get started in a study is to simply begin reading, or in our day, to use the internet and start studying and gathering basic information about a topic or a question we have. And then after we've gained information through reading, to then seek out opportunities to learn by practice, by handling things, by signing up for courses or an apprenticeship or lessons, and actually getting some experience. But we wouldn't rely just on a book to prepare for some kind of work. We should instead go to the shop and there learn to work with the tools of our trade. So, in the pursuit of scientific work, we must learn to use the tools with which nature has provided us. We need to use the tools that nature has given us for the pursuit of scientific knowledge. Our hands, our eyes, and the thinking mechanism, that is, our brains. It would be better for us to say reason. We need to use the tools that God has given us, our senses, and the faculty of reason, our understanding. We then see a quote from a famous naturalist or natural scientist named Louis Agassiz, where he says, study nature, not books. Study nature, not books. Remember, he's a naturalist. He's talking about the study of the natural world. He's not talking about all studies, just the study of nature. If you want to know nature in a scientific way, then study nature, not books about nature. So we've learned that knowledge in science, or scientific knowledge, can be learned from books where other scientists have shared their experiments or their observations. That's useful. But real scientific knowledge requires that we learn by observation. In the next section, we read about the classification of facts observed. The classification of facts observed. The knowledge that we gain by observation is worth very little to us or anyone else unless we use our minds to classify it and to apply it. To classify it means to organize it. So we can learn all kinds of information. We can gather all kinds of information by our experience, by experiments and studies and maybe trips to look at different animals or plants, visits to different places. We can gather all kinds of information. But that information is not very helpful by itself, and many people have minds filled with all kinds of disorganized information. And you may find people who just talk about things all the time, and they know all kinds of random information, random facts about all kinds of things, but it's disorganized and useless. It's just what's called trivia. It's useless knowledge. For our knowledge, for our scientific knowledge to become useful, it has to be classified. It has to be organized. We have to learn to order our thoughts, to order our knowledge, because that's what it means to have scientific knowledge. Remember, before I used the word systematic. That means that the knowledge that we have about a subject is organized. It's systematic. It's organized like the files on a computer or like the folders in a file cabinet. It's organized information. We don't just want to collect thousands and thousands of pieces of information and have them all disorganized and crazy in our minds. We want to classify our knowledge, to organize our knowledge, and we want to apply it. We don't merely want to know things, we want to use that knowledge. If we learn something, once we learn something, that becomes useful for us in solving other problems. If we don't use our knowledge, if we don't apply what we know, then it's useless. In religion, St. James said, "Faith without works is useless." If you have faith, but don't live according to that faith, what good is faith? The same is true with scientific knowledge. If you study and learn things about the natural world, but then face a problem and don't use what you know to solve that problem, what good is that knowledge? If your knowledge isn't classified and applied, then it's useless. We must find out what different facts mean as related to one another. We must not only gather information, but we have to reflect and think about the information that we've gathered and ask ourselves whether new information relates to any information that we already have, whether new observations relate to observations that we've had in the past. What is the relationship between new knowledge gained and knowledge we already have? Single isolated facts about the color, the coats, or the markings found on the coats of a kidney bean mean but little to us if we cannot correlate these observations with others and relate them to scientific truths already learned. A great many men working for long periods of time have gathered together a large number of single, isolated facts, have correlated these facts, and then have given to the world discoveries of worldwide importance. So when many discoveries are made, when many breakthroughs in science are made, when many inventions are developed or discoveries that solve great problems, it's because men find new information through their studies and they correlate that information. They relate it together with other information to solve problems. A careful boy or girl may, by his own painstaking work in science, find out some fact that is new, and in a small way make a new discovery. It is one of the most interesting things about science work that it has in it the spirit of discovery. Discovery is exciting. Finding something that has never been known before has to be one of the most exciting experiences in life. Just imagine being Christopher Columbus and sailing across the ocean, possibly for the first time in human history, and finding a new world. Imagine discovering the new world. Imagine a person walking through a forest who discovers a plant or an animal that no one has ever seen before. A new discovery. Imagine someone walking through a field and finding an entrance into a cave that no one has ever known about, and discovering an entrance into the world under the earth through a cave. Discovery is one of the most interesting things in life, and in the sciences, there are so many questions that still need to be answered, and there will always be new questions that need to be answered. There will always be scientific work to be done, work learning how to cure sicknesses and disease or solve problems, how to build things better, how to build houses better, how to build cars better, how to make clothing better, how to clean clothing better, how to grow food better, how to make healthier food, how to cook food, how to store food, on and on and on. There's always a need for new discoveries, new studies, new observations, new solutions, because there will always be problems that need to be solved. And this problem solving in the natural world, remember, this is only about material things. This is the work of science, scientific work. Now, in order to classify information, in order to organize knowledge, in order to know how to observe things, how to study things, in a general way, we have to know what to look for. We have to know where to start. How do we even get started with scientific learning? There are two important ideas that can help us, and they're listed in our textbook: morphology and physiology. Morphology and physiology. Let's read about morphology and physiology. It is evident that in order to understand the cause of the regular movements of a clock, it would be necessary to take the wheels of the clock apart and find out the structure of the different pieces composing the works, so as to see how these parts are related to each other. In the study of biology, it is usually found best to begin with the study of the form and structure of the parts of an organism. In biology, it's best to begin with a study of the form and the structure of the parts of an organism, and this study is called morphology. So, if we see an animal or a plant or an insect or anything in the material world and we want to study it, the first thing that we should study is the form, the structure of that organism, of that living thing. We need to learn how to study the actual body and its parts. This is called morphology. So if you were to look at a person, or if you were to draw a person, and you were to start looking at how all the different parts of the body are arranged, you would be studying the morphology of a person. And just so you know, this word morphology comes from Greek, and it means the study of form. Morphe in Greek just means form. Morphology, the study of the form of an organism. Next, we learn about physiology. Physiology. After we have discovered in the clock the form and structure of the different wheels and cogs, the different parts of the clock, and the relation of one part to the other, once we are able to take apart the clock, as it were, and see all of its parts and how they relate to one another, then we're in a position to put them together again and find out how they move and what causes the movement, how they work. We can study the use or the function of each part. The use or function of each part. The study of the uses or functions of the parts of an organism is called physiology. Physiology. So, two kinds of study, or two objectives that we have in our study in biology. First, we want to learn about the bodies of organisms. We want to learn about the parts that make up the body of an organism. And our first step is to simply learn about the parts. Then, once we know about the parts of the body of an organism, the body of a living thing, once we know about the parts of that living thing, then we can begin to study the functions of those parts, how the bodies actually work, how things work. That's what function means. So in biology, we study two things. They both start with the letter F. We study the form of organisms and the function of organisms. Form and function. Form and function. Form is studied in morphology. Function is studied in physiology. Form and function, morphology and physiology. Now, how do we go about these studies? Well, we do that through what's called an experiment. An experiment. This is where we organize an activity that will allow us to make observations about living things. We have to set up an opportunity to make observations. That's the experiment. In order to study physiology, and indeed most sciences, we frequently have to make use of an experiment. There are always 3 steps in a complete experiment. 3 steps in an experiment. Beginners in scientific study should always try to follow these steps exactly so that you make sure you learn how to carry out an experiment in the right way. When you get more experience, you'll be able to do these things more easily. But when you're getting started, make sure you focus on these 3 steps to complete an experiment. First comes actually making the experiment, actually making the experience. This includes collecting and putting together such materials as we may need. Collecting and putting together the materials that we may need for the experiment. A statement of the work we perform, and most important of all, a statement of the problem that we are attempting to solve. So the first step is setting up the experiment, setting up the experiment. State the problem, explain the experiment, and then gather together all of the materials and supplies that are needed to carry out the experiment. That's the first step. Set up the experiment. The second step is to make observations on the experiment which we have set up. The second step is to make observations on the experiment which we have set up. These observations may extend over a period of several days or even weeks. It depends on what the experiment is for. Our observations must be noted in such a form that we can use them in the third step of the experiment. So we need to take notes. We need to record our observations, whether we jot them down in a notebook or draw pictures or type them into a blog on a computer. We need to make notes and record our observations. The third step consists of drawing conclusions from the observations we have previously made. We have to draw conclusions. So after we've set up our experiment, step 1, and carried out our experiment, we've made our observations, we have to answer the question, so what? So what? What did we learn? What does our observation, what does our experiment actually teach us? We have to draw conclusions. We have to apply the information that we've gained by our observations. Every experiment should be illustrated with drawings to show all the apparatus used at each stage of the process. Now, this is an old book, so let's just make a note and say we don't obviously need to draw what we do. We don't need to draw the equipment and draw the things that we see and observe in our experiment, because most of us have access to cameras now, and we can easily take pictures. And it's very easy to carry out experiments and simply take pictures. It's great for a student who's interested in scientific study to create a blog on the internet where he can write about his experiments, share his observations, share pictures, share videos, on and on, to do this kind of scientific work. It's a great way to get started, and it doesn't cost anything because blogging is free. If you'd like help with blogging, get in touch with me and I'll explain what you can do. But we need to record our observations. We need to take notes about what we do in our experiment, because if our experiment doesn't work, if something goes wrong, we want to have notes and pictures that we can look back on and try to figure out what happened that caused our experiment to not be successful. And if we take notes and record our observations, take pictures, and yeah, draw pictures and sketch what we've done or what we've seen. Maybe if we don't have access to a camera at a certain time to be able to draw a picture, that's great. But we want to be able to do something with the results of our experiment. We want to apply and use our observations to draw conclusions and help us to move forward, solving the problem that we're working on or solve different problems later on. Our textbook then goes on to talk about using a notebook, and it's fine. You can set up and keep a scientific notebook. That's great. You can keep like a journal where you jot down experiments and observations and draw conclusions and write about things. But like I said, in our generation, we have so many amazing tools and resources like websites and blogs and cameras and video recordings and all kinds of things that I recommend that students learn how to use these modern tools for scientific work. And again, if you'd like some explanation or help learning how to do that, just get in touch. I'd be happy to show you. But the key is we'd like to record our experiments and observations and our conclusions that we draw from our experiments. We need to have a way to do that. Back in the 1950s, this would have been done through notebooks. But today we have more powerful tools and ways of recording things available to us that we need to learn to explore. Maybe I'll give a talk just on using technology in scientific work. And then we talk about the laboratory. The laboratory is simply a place where experiments are conducted. Sure, you can go outside in the woods or go out to the ocean or to a nearby lake or river and observe things, observe living things. That's biology. That's the work of biology. You can set up experiments outdoors, but sometimes it's helpful to have a place, maybe in a school, you can have a real laboratory, but at home, you could have an area set up in the kitchen or maybe in the basement or out in the garage, maybe in the backyard in a shed, where you can carry out scientific experiments, where you gather together some tools that you need and equipment and supplies that you need to carry out experiments. The book talks about that a little bit, and I'll leave you to read that on your own because we could talk about that for a long time. So set up a place where you can keep materials and supplies that you can use for scientific work and carry out experiments. You don't want to set up an experiment and have your brothers and sisters or cats and dogs running around and knocking things over, messing things up. You might want to find a place where you can carry out experiments and not have to worry about things getting messed up or touched. So your experiments are able to be carried out over time. So you may need to set up some kind of a laboratory, not a big expensive laboratory like in a college or university, but something simple, a place where you can work. That's what laboratory means, a place to work. And lastly, when we talk about instruments that are used, basic instruments, things needed to carry out experiments, things like microscopes or telescopes, different tools. You'll learn about these things as we go through different lab activities. But again, in our generation, we have access to so much content, so much video and pictures and recordings, all kinds of content that we don't necessarily need to conduct the experiments ourselves to see and learn things. There's so much recorded evidence of experiments done and studies people have done that we can often find the observations that have been made by others and shared in helpful ways without collecting all kinds of equipment and instruments for ourselves. But if you're serious about scientific work, you may want to look into asking for a microscope for Christmas, or working and saving up money to buy some tools and supplies for biology experiments, to keep some animals, to keep a fish tank, to keep different plants in a garden or plants inside a house for study and observation. You may want to do those things, and we can always talk about that if you have questions and specific things you'd like to do. So that brings us to the end of this first lesson and to the end of our first hour. I don't want to keep you any longer. That was a long lesson. I hope that was a helpful walk through this first lesson, this introduction to biology. I recommend that you read through this lesson on your own and study it for mastery. You can listen to this talk again if you'd like to, but that's an hour of instruction in biology, and we've completed our first hour in freshman science. God bless your studies.